benefit of the doubt that you did it, being that you'll have it done by the time I get through, right?
Sir, are we gonna need the chart thing on the test?
Yeah, but I'll make copies. I'll make sure you have that. Oh, is Gio here?
Of course he is.
All right. Hurry up, please. Don't trip on the hall. We'll laugh. All right. So, Swanee still hadn't made it yet? Okay. All right. So, I am on page 85. That's what I had assigned you. If you didn't get it done, copy this down, and I'll give you the benefit of the doubt that you were here, so we did it. Preparation for this week. Let's see, today's Tuesday. We'll finish up with the 510. We'll start reviewing. We'll review a little bit more tomorrow. And unfortunately, we have a 2-day quiz. One of the days will be all multiple choice. One of the days will be short answer. And so I'll provide you an extra one of those T-table charts in case you can't find yours. Of course, you can use as many note cards as you want, which kind of makes it fun. Okay, so let me ask you this, I'm just curious because I haven't taught confidence intervals for 21 years. It's been quite some time since I've taught it, and I'm just curious. How are you feeling with using a confidence interval? How confident are you? I taught you learned confidence intervals. Okay, I'm just kidding. Are you okay that that you get a range of stuff, and then there's all types of levels that you can be confident? Of course, when we said the 99.9% confidence interval, you are talking about almost the entire area underneath the curve that you're talking about. But if you got to like a 50% confidence interval, that's also not necessarily a good thing, because a 50% would be like half the area under the curve. Let's pretend I can draw half really good under a curve. So that there's just different ways of doing it, and it's just a way of you, if you were to read something or if you were to actually create some sort of study, that the reader of your study would know. And the one thing that I hope you're starting to realize with statistics is there's no guarantees. It's just collecting data, recognizing a pattern. As we move through into chapter 6, chapter 6 was dealing with some called the hypothesis and the null hypothesis, which that becomes kind of almost legal jargon you're using for statistics. And it kind of seems funny, because if the more and more you start realizing how statistics works, the more and more you'll start realizing we're really pretty unsure of stuff, though we have certain intervals that we feel could happen of different events. So, and that's just the ins and outs of just statistics. Okay, so page 85, it's on 510, it says, to estimate the percentage of Colorado pine trees that are infected with pine beetles, nature researchers construct a 99% confidence interval that takes place. Okay, so if you've been up to the Central Rockies, you realize we don't have something called evergreens anymore. They're called evergrays, because they're all gray and dead. And I've heard all sorts of speculations why the beetle kill has done this, and it all falls into statistics. And I hear reasons where it's like, that sounds like a good reason, but because it sounds like a good reason doesn't mean it's actually the truth. I heard my wife teaches, and I'm sure you know this, she teaches at CU Denver. She teaches chemistry for engineers. And there have been times, oh, we have Valentine's. All right. Let's see. I got this student and I have both of these people. Cool. Yeah. So, don't worry, it wasn't an escort one. So this particular professor, who we were at a dinner in downtown Denver, what I have noticed from at different levels of education, if we have a dinner as a staff, it's nice, it's good. When you have dinner with the spouses and all the staff for a university, it's really pretty good. It's approaching Cherry Hills Country Club pretty good, which is always kind of fun. But there was this professor who teaches environmental science, has a PhD in something as far as environmental science. And this professor said that the reason that we have so many beetles destroying our forests in the particular pine trees is that our winters don't have a deep enough or a far low enough average freeze, meaning the temperatures in the mountains aren't as cold as they had been in the past. And what had happened with the beetles had always been there, but because during a really hard freeze, the beetles larvae, which they lay their eggs in, for the winter, and then come springtime, they all hatch and start munching on trees. Because the hard freeze wasn't taking place, it wasn't killing off a large enough amount of beetles. Now, I'm hearing this from somebody who has a PhD in environmental science. So you would think that he is definitely an expert on environmental sciences. So it seemed like a really legitimate thing. But I wasn't going to debate the guy on what he was saying. I listened to what he said. It was just a side conversation while, I'm trying. Anytime I go to those dinners with my wife always looks at me and says, "Don't say anything." Okay. So I usually just, eat food and drink wine and listen to what people have to say who have higher degrees than me. But after he said it, I kind of started thinking, okay, this seems like a legitimate thing to say, but does he really have the data and the statistics that would formulate that would be a valid conclusion for it? And the hard thing is, a lot of people with higher degrees, I'll give them the nickname PDs, for prima donnas, because their education sometimes gets in front of what's truly the true facts, because being that they have a PhD, they understand much better than most. And it seemed like a legitimate thing, but again, I'm not quite sure. I mean, there might be some definite other factors that might have taken place. Things that I don't know, but I'm sure through research could find out. Have we always had these beetles in the United States? And that I don't know, but it is very possible. I know that those Japanese beetles that come around, and it probably drives, if either your parents are gardeners, probably drives your parents nuts. It drives me nuts because I garden during the summer, and these little critters, though they're such a pretty green and yellow color, these things multiply faster than bunnies. I mean, they're crazy. But I know that the Japanese beetles, because that's their name, were actually imported to the United States inadvertently, because somebody at some point said, I used to have this really pretty plant bush tree in some other country or some other state. And they decided, we want that here because that's they want to be reminded of home. There was a tree in Arizona that people decided, oh, we have to have these trees because they're awesome. They grow in the Mediterranean, therefore Arizona, that is, hotter than you know what, we should grow these trees. And they brought these trees to Arizona, called the Russian olive tree.
Oh, yeah, that's huge.
And it actually became illegal to plant the Russian olive tree because the allergy that people have to these was through the roof. And it had this yellow pollen that would go everywhere. And you'd be out, because when we were kids, we would go outside and play. And you'd come home and you'd be congested and your eyes watering and back in the 70s and 80s, it was like, I don't know what it is, you're allergic to something out there. Well, everyone was allergic to these Russian olive trees. So fortunately, they banned people planting them any longer in Arizona. And then Arizona, because it's gone through such a huge drought over the past 20 or more years, this particular tree requires a large amount of water. Being they want to save water, people started chopping trees down because they hiked the rates of water up. So where people are like, I used to pay $5 a month for water and I could just have my garden hose on nonstop. Now I'm paying $500 a month if I have that same habit, which people didn't like. So there's just different aspects to it. So come in circle of what I was saying. Sometimes when you hear from somebody who has a PhD, I'm not discounting what they know. I'm not trying to say that. I'm just trying to say that a lot of times that their ego will get in the way of their degree, and they will put out a blanket statement that sounds intelligent, but it might not always be true. So I don't know if this beetle kill from this thing was because our winters aren't necessarily as cold in the Rockies as they had been. So that's just some speculation, and again, I don't know. So it says to estimate the percentage of Colorado pines that are infected with pine beetle, nature researchers constructed 99% confidence interval. Okay, so we're talking about 99% of the area underneath the curve that we're putting our thing. So we're very sure that we could say this. And then it says the interval is 8% to 18%. Okay, so interpret the confidence interval. So we're 99% confident that between 8% and 18% of the pine trees are infected with pine beetle. So we're 99% confident that this information will fall within that region. So is it possible there could be only 7% trees with it? Yes. Is it possible there could be a higher percent than 18%? Absolutely. So interpret the confidence interval. We are 99% confident between 8 and 18% of the pine trees infected with the pine beetle. Okay. So that's number one. Number two says interpret the confidence interval. And then it says 99% of all random samples will produce a confidence intervals will capture the true percent of infected trees. So again, remember when we talked yesterday, we had kind of like these lines that were doing this, and some might have been longer, some might have been shorter. So what this 99% confidence interval is, if I had 99 studies, they would somehow have an average, and again, we don't know what the average is, but if we had 99 studies, 99 of the, or if we had 100 studies, 99 of them would fall within this. We would have the one that would fall outside of it. And I realize I haven't drawn 100 lines, and I'm not going to draw that, but that's basically what it means. So there is a chance that you have a study of 100 different studies of trees, of these particular trees, that would show that you're going to fall between 8% and 18% of those particular trees are infected, okay, or have these beetles that are eaten from the inside out. And that's what kills the trees, okay? So that's kind of a little bit of the gist of 1 and 2. After that, it says use the confidence level diagram to answer each of the questions. Okay, so we have 8, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like we have 10 studies that have been done. One of those studies is outside of the average, okay, or what we think is the average. Okay, so this is assume the parameter of the population value we're trying to capture is 100. What percent of the confidence intervals failed to capture the parameter? Well, 1 out of 10 is 10%. So on this next one for numbers, number 3 beyond, 10% won't capture. And the reason we say it's 10% is it looks like we had 10 studies. One of those didn't go, so we could assume that if we had 100 studies, 10 of those studies would not fall within the average we think is what we're supposed to be in at. Okay, so number 3 said, we said 10%. Which interval had the most accurate estimate? And so for number 4, which had the most accurate estimate would be, we could say a couple of them. J would work, F would work, D would work, and A would work. Okay, now the reason why A, D, F, and J work is your average line is here, and for each of those, they're different lengths, but you have about the same distance above and below. Okay, so that's what you'd be kind of looking at on that type of situation. Okay, so that it looks like right in the middle of each of those would be our weight that we're trying to capture. Which interval had the largest margin of error? So number 5, the largest margin of error, let's see, would be letter C. Okay, so the largest margin of error is you are far above or further above and below all the other studies. Okay, that's basically the in and out to that one. Which interval failed to capture the parameter? Well, I didn't work because if you looked at your average, I happened above it. Okay, so we had something like this for letter I. So that failed to capture where our parameter was. And again, the parameter is where we think our information should be. We're hoping to capture somewhere within that region. And then number 7, explain why it is unlikely but not impossible that the confidence interval used was 99%. Well, right now we see that 10% failed because we had 10 studies. One of them failed. 1 out of 10 is 10%. But if we use 99%, we would expect only 1% to fail. So, is that accurate? It could be. It could be letter I. If we had A through Z, 3 plus times, not quite 4 because there's 26 letters in the alphabet. It's pretty unlikely that if we continued our studies that we found the 1 out of the 100 in our first 10 studies. Okay, so it's pretty unlikely because the 10%, so the 10% that we found, could it go to 1%? It's possible, but not likely. Okay, and that's kind of how we estimate these. So this was a little bit of an easier thought process than some of the other things in the chapter. But I just wanted to make sure that you're feeling okay about these confidence intervals. There's a reason why we use certain tables for certain events, and hopefully our review might look okay. So where are we at? So I'll go a few minutes. Let's just talk about a couple of these. I am now on page 86. And I think from page 86, you will probably be able to generate, actually, I take that back. I'm not going to be on page 86. No, 86 is fine. Okay, so problem number 1. It says, calculate the confidence interval, interpret each meaning, show the setup. So as a random sample of 1,000 pieces of mail was inspected, and 460 of them, 460 of these pieces of mail were from advertising. Okay, so we had 1,000 mail items, and then we saw that 460 of these were advertising. Okay, so I used to anytime during the summer, I really probably shouldn't have summer because I get bored. So I get these pieces of mail, and they'll have an envelope that is, I can mail it back for free. So I usually will rip up the original item, stuff it in the envelope, put it back in the mailbox, so then the U.S. Postal Service gets the money for it. So I'm trying to help out the Postal Service.
Right.
And I'm sure those guys at these companies going, Chris Stirrup, you have too much time on your hands. Okay. So construct a 95% confidence interval to attempt to capture this thing. So what do you think? What should we do? This goes from 5.6 to 5.8, so where should we go, you think? Okay. So let's go back to 5-6. So 5-6 is the same idea. Where am I looking? 5.6. Maybe it's in 5.7. So we're going to do, for this 95, we're going to do the Z star root P1 minus P over N. Okay, so what we're going to do is we're going to do inverse norm to find our Z score. This is going to find our Z asterisk of, are we going to use 0.95? No, what should we put in there? 0.975. You're exactly right. Why is that? Remember, this has to be the halfway to 100. So I'm 5 away from 100. Half of 5 is 2.5. Add 2.5 to the 95. So we'll do the inverse norm of that. And then under our thing, well, we have to realize, okay, I have 460 divided by 1,000. Somebody have a calculator? You can just give me that decimal roughly to 2 places. 460 divided by 1,000 or 46 over 100?
It's just 0.46.
Just 0.46. So I'm going to go 0.46, and then I'm going to go 1 minus 0.46 over our number of items, which was 1,000?
Yeah.
Okay, so that's our sample size. Okay, so I need some help. I don't have my calculator. Anyone have one, or can you grab one out of the cupboard for me, please?
I got 1.96
You did the whole thing?
Yeah, so 100 minus 95 is 5. So it should be the inverse norm of 0.975.
Right, so which number are you giving me? Did you find me the inverse norm already?
Yeah, that's 1.96.
Okay, so we get 1.96. And then what does this come out to be? Including, or what is it before the square root? 0.46 times 0.54 divided by 1,000. Anyone calculating it?
Yeah, hold on. So 0.46 before the square root?
Yeah, before the square root.
Okay, so 0.46 times 0.54 is 0.2484.
Divided by 1,000.
Yeah, that's, okay, 0.000244.
Okay, 1.6 or 1.96, or what's the square root of
Um, 0.015.
0.015?
Yes.
1.96 times that?
0.0294.
0.0294?
Yes.
Okay. So, what are we going to do with that now?
So that's the margin of error.
Mm-hmm.
So we have to add and subtract it from the point estimate.
Mm-hmm. Your point estimate is?
I'm not 100%, but is it 460?
Isn't it 0.46?
Well, what, is that how?
I would go,
Will be,
I would use that decimal.
okay.
So 0.46 plus or minus 0.0294. So if we add that, I'm going to get 0.4894. 0.46 minus 0.0294.
0.46. Oh, 0.46, sorry. 0.46 minus 0.4306.
There's 6. Okay. Okay. So this basically, so being that we converted all of these to decimals, we could, if we wanted to, say it's between 43.06% to 48.94%. Sometimes that becomes a little easier to fathom. So that would be our confidence interval. Do we answer that? Yeah, that's our confidence interval. So that's our confidence interval. Okay, so what would, and the reason I did a whole lot of that is I think that might be something that you might want to try and squeeze on one of your many note cards, because this one was done a little bit differently because we had to figure out the percent first. We didn't know that. We knew we had 460 over 1,000, and there was 1,000 that were selected, and 460 were advertising. So we are 43.06 to 48.94% sure that 95% of our information would fall within that parameter. Okay. Critical value, we found that, didn't we? The critical value, so for B, the critical value was, I had labeled it someplace, 0.0294. Is it 0.0294?
The critical value is
Yeah.
1.96. The margin of error is 0.029.
Yeah, so critical value 1.96. And then C, is there estimate here for the statement, less than half the mail advertising? Okay, so is there evidence for the statement, less than half of all mail is advertising? Explain.
I mean, wouldn't it be, there is evidence of that because the entire confidence interval is below 50%?
Yeah, that's exactly right. That's exactly what I was trying to get you to say. So, less than half, so less than 50%. Well, being that this is definitely less than that. Now, is there a chance that 49.6% is? Sure. But we have evidence to say, I mean, if this was, being that 50% is truly less than our confidence interval, I think we could say it. If this value here was, like, let's pretend it was 65% and this stayed the same, there is kind of evidence, but unfortunately, I can't make that kind of statement because if that right side of my information was beyond that, I couldn't say. There's not enough information to make that kind of statement. Okay? So let's stop there for today. All I really want you to do is I want you to start really focusing on things that you're going to put on your note cards. And again, you can have as many note cards as you want, but let's make sure that you have the information you need. I think that's a valuable question to have listed. I have it recorded so you can do it. And then if anyone wants more note cards, kind of like what Kim's been doing, where you reduce it down and you cut it down to this size. I like that. That's a good idea. So say